Hello everyone, good afternoon. Today we'll be going over and exploring software cost and the challenges presented in software and just exactly what that might look like and entail. This will be a two-part series and I will be going over the first half today. But without further ado, let's jump right in and go on to our next segment. Right, so our next point is going to be covering the cost of software engineering. So, software engineering cost often exceeds system cost due to the outgoing need for updates, bug fixes, and improvements over time. So, maintaining software accounts for over 60% of the total development cost. And this is because once a system is deployed, it requires continuous monitoring, updates, and patches to ensure that it functions properly and that it meets the evolving user needs and that it stays secure. So of the maintenance cost, 20% is for corrective maintenance, meaning that it addresses issues and bugs that arise post deployment. And then 30% is adaptive maintenance, meaning that it ensures that the software can work with new environments, platforms, or hardware. And next we have 50% is for perfective maintenance, which means it's focused on enhancing the system's performance or adding new features to keep it competitive and aligned with user expectations. Alright, here we have a graph about the cost of fixing software issues. And here we can see a better example of software cost and just how it is distributed. We can see the different ranges for how costs are allocated and see where the areas might be checked and revolve around. We see that some areas are way more funded than others and might have more associated issues with them. So we can see that all the way at the top right, we have maintenance, which is at the highest, and at the lowest, we can see requirements, right? And all these range from the different costs and the software specifications for each one. On to our next point, we have unique challenges in software engineering. So the first is complexity. Software systems are made up of many interconnected parts that may not be identical to one another, making it difficult to predict their behavior or manage them effectively. The complexity increases as new features are added or the system scales. Next, we have changeability. So unlike physical systems, software is highly malleable. While this allows for flexibility, it also means that continuous updates, modifications, and bug fixes can introduce new issues and require constant work or reworks. Next, we have conformity. So software always needs to evolve to meet changing requirements, user demands, and technological advancements. So this need for continuous adaptation can create challenges in maintaining stability while integrating new features. Next, we have invisibility. So while software is intangible, it can't be seen or physically interact with in the same way as hardware. This lack of physical presence can make it harder to grasp, manage, and troubleshoot, and it often leads to misunderstandings or miscommunications about its needs or issues. So our next point will be about the key challenges of software engineering. So our first example is legacy systems. So these are older software systems often written in outdated programming language or built with obsolete technologies, making it difficult to maintain and integrate with modern systems. They may also lack documentation, making updates and bug fixes more challenging. Next, we have heterogeneity. So this is software that needs to run across a variety of platforms, devices, and environments. This diversity in hardware, operating systems, and user interfaces can complicate development and testing, as developers must ensure compatibility and performance across multiple systems. And lastly, we have delivery, which is the timely and efficient delivery of software remaining a significant challenge. We want to ensure that software is delivered on schedule, within budget, and with the desired functionality, requiring effective project management, collaboration, and continuous testing throughout the development lifecycle. So, in conclusion, we have seen the many different aspects of where software costs go and the unique challenges and issues presented with each type. I hope this has given you a better understanding of just how far software-related issues go into more depth, and stay tuned for part 2 that I will release later that will cover a bit more about this cost and go on to other things. Thank you for watching, and please feel free to like, comment, share, and have a good one. Thank you.